In this lesson video, we're going to connect potential to our growing understanding of electric fields. You first learned about potential years ago in terms of potential difference, but hopefully now you're a little bit more comfortable dealing with potential by itself. Let's start by looking at this uniform electric field. Remember, charged particles experience a force in an electric field which will make them move. Setting up a potential difference is the most obvious way to make charge move, so clearly a potential difference, like the one between these two plates, creates an electric field. Let's say this positive plate is at 400 volts and the negative plate is at 0 volts. What's the PD here, going from here to here? What's the PD? If you said 400 volts, then surprisingly, you're wrong. Have another think. Well, to calculate a change, you should do final minus initial. So this is 0 minus 400 equals minus 400 volts. Now I'm not just being annoying, it's going to be important later on. The PD is minus 400 volts. Note that I could have made this 200 volts and this minus 200 volts. Or make this one minus 1000 volts and this one minus 600 volts. And we'd have had the same PD in any case, so there's no real difference. Anyway, let's go with 400 and 0. Now, consider this point, halfway between the parallel plates. What's the potential here, do you think? Do have a think. Well, it's halfway between, so it will split the potential. It will be 200 volts. How about here, halfway between the plates? Hopefully you said 200 volts again, and it's going to be the same along all these points. If I join them with a dashed line, we can say that at all points along this line, the potential is equal. So we call this line a line of equipotential. This line of equipotential can have the label 200V. How about here? It's between the 400 volt plate and the 200 volt equipotential. So it's going to be 300 volts. We can draw another line of equipotential here. And here. With some labels. See how the lines of equipotential cross the field lines at 90 degrees. Now that's important. If I plot distance from the positive plate against the potential, we get a line. Like this. It has a negative gradient, of course, because as distance increases, delta V is negative, as I pointed out earlier. So, there we have a complete diagram for a uniform electric field. Two plates, field lines going from positive towards negative with their arrowheads, and lines of equipotential. Let's look at another one before finishing off. This is for a non-uniform field. Notice how the rules for field lines and equipotential lines are still followed. But also notice that the lines for equipotential are not evenly spaced. They are further apart as we move away from the charges. So in this lesson video, we have reviewed potential in electric fields, And we've looked at it in terms of uniform and non-uniform fields. But we've been a little bit limited, so in the next lesson video we're going to look into the potential gradient and see how that can really help us to describe the electric field strength.